This video is on section 3.1, measures of center. So in chapter 1, we talked about some vocabulary from statistics as well as different methods of sampling and bias and things like that. Chapter 2, we talked about different ways to display data. And so now we're going to look at different ways to compute, to do some computations with data. So first, we have measures of center, and the four vocabulary terms we're going to look at are mean, median, mode, and mid-range. So the mean is the sum of the data divided by the number of pieces of data. And this is the formula we have written out. So X bar is the shorthand we use for mean. Sigma, this is the Greek letter sigma of X, would be the sum of all the data values. Sigma is what we typically use to shorthand that we want to add a lot of things up. And then N is going to represent the number of data values. So if you have 11 different pieces of data, you're going to add 11 numbers together, divide by 11. The median is the value in the middle of a set of ordered data. So you either put it in descending order or ascending order, and then choose the middle number. If there's an even number of data, then it's the mean of the middle two numbers. So take the middle two numbers, add them together, divide by 2. The mode is the piece of data that occurs the most frequently. It's possible for there to be no mode, and it's possible for there to be multiple modes if you have some data that occurs 3 or 4 times and another piece of data that occurs the same number of times. The mid-range is the middle of the minimum and maximum data values. So to find the mid-range, you just take the lowest value and the highest value and divide by 2. A statistic is resistant if the presence of extreme values, we know these as outliers, does not cause it to change very much. So we would know that maybe one of these is a good measure of center if it's resistant, if outliers are not going to impact that value. So there's one in particular that we will think of kind of as a great measure of center, and that is the median. This one is resistant. The outliers are going to be either very low numbers or very high numbers. And since the median is based on the middle number, you don't use the outliers. You tick them all off one by one, and then you end up working with the middle. With the median, half of the data values are below it, half the data values are above it. So it's a pretty good measure of the center. 2 that are definitely non-resistant are the mean. This is not resistant. The mean is not resistant because you are adding all of the data together. You're adding the outliers in there. So if you include the outlier, your mean is going to look one way. If you decide to exclude your outliers, your mean is going to look a different way. The mid-range is another one that's going to be very impacted by an outlier because you're using the minimum and maximum values. So if you have outliers that are very low and outliers that are very high, then your mid-range could be calculated using only outliers, and then it may not really reflect the data very well at all. So this is definitely not resistant. The mode is pretty resistant. Odds are you're probably not going to have an outlier that's a mode, because that would mean that it's repetitive, right? And that would make it maybe not an outlier after all. But the mode generally isn't a great measure of the center. just especially when there's multiple modes, then what do you do? Which one would you actually say is the true center? So it's interesting to find, but it's generally not what we're going to go with as far as the best measure of the center. But it is good data. It is good information to find. It's an easy computation to get. So it is something that we'll look at. But if you are talking about which one is resistant, which one is not impacted by the outliers, then that would be the median. All right, so we're going to look at an example. The example says the salaries of 10 employees of a small company are listed below. So these are all salaries. They're in dollars. Compute each of the measures of center. So for the mean, we just had to add them up and then divide by 10. So we have 25,000, 26,000, 27,000 times 2. 28,000, 29,000, 30,000, 32,000, 65,000, 82,000. Typically when I'm doing this, I add my numbers up more than once to make sure that I've got the right answer. But I've already done this, so I know that I got it right. So we have $371,000 total. And when I'm showing my work, I often write that out. So my sum was 371,000 total, and I'm going to divide it by 10 because there are 10 salaries. And so the average, the mean would be 37,100. And we'll talk a little bit more later on in the notes about why I caught myself when I said average. Okay, the next is the median. That's the one that's kind of in the middle. So highest, lowest. So these two are smack dab in the middle, 28,000, 29,000. So we would do 28,000 plus 29,000 divided by 2. And the middle of that would be 28,500. The mode is the salary that happens the most often. In this case, there's only one salary that happens more than once. That's 27,000. And then the mid-range is the lowest salary, 25,000, plus the highest salary, 82,000, divided by 2. $53,500. Okay, so these are 4 different measures of the center of the data, just depending on how you want to view it from what perspective, and maybe what you want the data to say, which is kind of what our next couple questions are going to go through. So if employees wanted to argue the need for a raise, which measure would they use and why? So if I was an employee and I wanted to argue a raise, I'd probably go with the lower numbers. And then I would use those to argue that we should be getting more money as employees. So the mode, 27,000, the median, 28,500. You could go with the mode of 27,000, but that might be something that an employer could easily shrug off. Say, well, of the 10 employees, only 2 people make that. There are plenty of people that make more than that. And so you wouldn't want to be shrugged off. So maybe in that case, the median might be the best to use. The median would be a great measure of center to use here because it's still a pretty low value, but it's a resistant value. So it's representative of a typical employee. And it's resistant to outliers. And if you look at the data, you can see that 25, 26, 27, 27, 28, 29, 30, 32, those are all kind of similar salaries. They're going up, you know, by 1,000 or 2,000 or whatever. And then you jump 65,000, 82,000. So here we're probably talking about managers, maybe the person who started the company, the CEO of the company. So we went from kind of your typical worker to somebody who has a lot more responsibility and a larger stake in the company. So if we're arguing for most of the employees, then we probably want a measure of center that's more representative of them, that can't as easily be talked away or shrugged off. If management was trying to hire a new employee, which measure would they use and why? So if they're trying to hire a new employee, they probably want to bring that person in with the promise of making more money. So maybe we would go with like the mid-range or the mean, but we would want to be careful, because the mid-range might not be a great value. If they make a promise with the mid-range to draw people in, then when people get the job offer and it's a lot lower than that, they might turn it down. So the mean might be a better value to use because it's a little bit higher. More people are going to be interested in applying for the job and interviewing it. But it's not so high that if they got like a lower offer, it'd be, you know, you could explain it away. You could say, well, you have to be at the company for more years to be able to get a number that high. So I would say probably the mean. Okay. Next says, which measure do you believe is the most descriptive of the data and why? I would say probably, in my opinion, the median. And the reason I would say the median is because half the data is below, half the data is above. It's also resistant. But some people might say the median's not a good measure because it only really considers the company from the employee's perspective. If you really want to include those outliers, because those two outliers are people who are employed by the company, then maybe the mean is a better descriptor of this data. Maybe it's a better measure of center because it considers every value in the whole company. So when you're answering a question like this, which measure do you believe, you can truly say which one you believe. You just have to have a reason to back it up. And the reason that you're using needs to be mathematically sound, needs to be something that makes sense and shows understanding. And as long as you do that, then your opinion questions will get full credit. So you don't have to worry about, well, what's the actual right answer? You're allowed to have opinions, just make sure you back them up. Okay, next we're going to look at another example. If you look in your textbooks, there's Appendix B, which has different data sets in it, and data set 33 is referenced, and it has different wait times for popular rides at Disney World. And if you look at triolastats.com, it has like the full data set. So what we did, they did this in the textbook, and then I went ahead and used the same data. They took the first 11 wait times for Space Mountain at 10 a.m. And there were hundreds of data points, but we just used the first 11. So we're going to go ahead and compute the measures of center. The textbook gave us some rules to consider. So if you're using the mean, median, or mid-range, then when you're doing those calculations, you can carry one more decimal place than is present for the original set of data values. So if you had a whole number, then when you do rounding, you could round to the nearest tenth. If you had a number that was already a decimal and it had 3 decimal places, then when you do your computations, you could do to 4 decimal places. The exception to this is the mode. You should leave that without rounding. And that's because, you know, the mode is from values that are already there. Okay, so we're going to compute all of these, find the mean first, so we're just going to add up all of these values. 50, 25, 75, 35, 50, 25, 30, 50, 45, 25, 20. So the sum is 430, and we're going to take 430 and divide it by 11 to find the average, because there were 11 times. So it'd be 39.1, the 0 is going to round to a 1, 39.1 minutes would be the mean for the wait time. For the median, we need to put our data values in order. So the smallest data value that I see is 20, then 25, 25, 25. 30, 35. 45, 50, 50, 50, 75 is the largest. Okay, so the median is going to be right in the middle. So of 11 data points, you'd have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is right in the middle. So 35 minutes. The mode, there are 3 25-minute waits and 3 50-minute waits. So the mode would be 25 and 50 minutes. This data would be bimodal, 2 modes. The mid-range, we're going to take the lowest value and the highest value, divide by 2. So 20 and 75 is 95 divided by 2 is 47.5 minutes. Okay. Next example. A mean between 80 and 90 for 5 exams is needed for a final grade of a B in a class. Jeremy's first 4 exam grades are 73, 69, 85, and 80. What score does he need on the last exam to get at least a B in the class? So he has a 73, a 69, an 85, and an 80. And then he has some unknown 5th grade. We're not sure what this one's going to be. When you take all those grades, if you divide all those by 5, then his grade needs to be between 80 and 90 for him to get a B in the class, or higher than that if he's going to get an A in the class. So I'm going to set these inequality symbols, and I'm just going to say between 80 and 90. So if I want to solve this, I've got all these numbers divided by 5, and I can go ahead and just add these up right now. 73, 69, 85, 80, 307. Okay, so I'm going to go ahead and multiply by 5 to get this divide by 5 off the bottom. So if I do times 5, times 5, times 5, then I get 400 and 450. And then I want to figure out what this unknown exam value is, so I'll subtract off these other exam values. So 400 minus 307 is 93. 450 minus 307 is 143. So this says that to be able to get at least a B in the class, he has to have between a 93 on the exam and 143 on the exam. 143 does not make sense. So we would say, well, he needs to get above a 93. Or I could say, I don't know what grade he's going to get if he gets above a 93. I could say to get at least a B. Okay. I know he can't get 143. 100 is where that exam probably is going to top off. You know, maybe the instructor gives over 100%, gives some extra credit, but we can't guarantee that. So let's take these scores, 73, 69, 85, 80, and let's go ahead and add a fifth score. And let's just say he got 100% on the last score, and we'll see what his highest grade could be. So that adds up to 407, which makes sense, 307 plus 100. Divide it by 5 scores. The highest possible score he could get in the class is an 81.4. So he can get a B, but he cannot get an A. Oops, he cannot get an A. Okay. This was a caution, like a warning in the book that I just wanted to draw attention to. It says never use the term average, which is why I caught myself earlier. When referring to a measure of center, the word average is often used for mean, but it is sometimes used for other measures of center. The term average is not used by statisticians, and it will not be used throughout the remainder of this book when referring to a specific measure of center. The term average is not used by the statistics community or professional journals. From this point forward, it would be wise to abandon use of the term average when referring to measures of center. So if you want to use the word average when you're just talking in a math class or whatever, that's fine. But in terms of statistics, when we're talking about mean, median, mode, and mid-range, we're going to say measures of center and refer to them specifically.